Section 6.1 is about proportions. Hopefully you remember a little bit about proportions from Algebra 1. The definition of proportion is it's a comparison of a ratio is a comparison between two quantities. It can be expressed as a fraction. For example, the ratio of boys to girls at a party. If you have 10 boys and you have 2 girls, you would have a ratio of 10 to 2, but you're always going to reduce to lowest terms, so you would have a 5 to 1 ratio. Sometimes it's written like this, and sometimes it's just written like that. So it can be written as a fraction, it can be written with a colon between it, or it can be written with a number 2 between it. If you have 2 ratios that are equal to each other, it's called a proportion. So a proportion is an equation stating that 2 ratios are equal. Like for instance, 10 to 2 is the same thing as 5 to 1. Those 2 proportions are equal. You can always test to see if they're equal by multiplying up. That gives me a 10. Multiply up. That gives me a 10 as well. So I know that that is a proportion, which is 2 equal ratios. The ratios that are written as proportion have descriptive terms. The extremes of the proportion is the first number and the last number. So the 2 and the 33 are called extremes, and the 3 and the 22 are called means. Okay, so the first and the last, if you go dun, 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 the first and the last are the extremes. The 3 and the 22 are considered to be in the middle, and they're called the means. Okay, you can solve proportions that have variables in it by using cross multiplication or cross products. So I'm going to multiply this times this, and this times this. So I have a 5x is equal to 225. And then to solve this, of course, I'd have to divide both sides by 5. So I get x is equal to 45. So that would be what the value of the x would have to be for those 2 fractions to be equal. Now on this particular problem, which is the same as this, it can be done a different way. I can say 5 goes into 75 how many times, and it's going to go 15 times. So if I multiply the top and the bottom of this fraction by 15, it tells me what x would have to be equal to. X would have to be equal to 45. It's like renaming a fraction with a common denominator, if you will. Like if I wanted to rename 3/15 into something over 75, I would say, what times 5 is equal to 75? And I would have to multiply the top and the bottom by that. Now, that method does not always work for every proportion. This method does. That's like a shortcut on some of the problems. Like, for instance, it doesn't work on these with variables on it. So you're going to do it the long way. You're going to cross product. Don't forget to do distributive property when necessary. So on one side I have a 2 times 3x minus 5. This times this. And on this side I have a 4 times 13, which is a negative 52. So I have to do distributive property here. So I have a 6x minus 10 equals negative 52. And then I'm going to have to add 10 to both sides, which is going to give me 6x equals negative 42. And then I'm going to divide by 6, and I'm going to get x is equal to negative 7. Okay, might as well do this since I'm right here. I'm going to cross product here and here. So I have 6 times 4x minus 5. And I have 3 times 26. So that's going to give me a negative 78. I'm going to do distributive property. So I have a 24x minus 30 equals negative 78. I'm going to add 30 to both sides. And I'm going to get 24x is equal to negative 48. I'm going to divide by 24. And I'm going to get x is equal to negative 2. All of this is strictly algebra. You saw it first in Algebra 1, I'm sure. Okay, this is going to be 6y is equal to, let's see what that's, 18.2 times 9, which is going to be 163.8. I'm going to divide both sides by 6, and I'm going to get y is equal to 27.3. That should all be review information for you. So now we can do some word problems involving these proportions. So the ratio of 3 sides of a triangle is 9, 8, and 7, and its perimeter is 144. Find the measure of each side. There's 2 ways to do this. One way is you put an X with each of those numbers, because I really don't know what that side measurement is, but I know it's going to be something times 9, something times 8, and something times 7, and it's going to be the same something for each because they're going to be proportional like that. So if I do it this way, I've got 17x plus 7, so I have 24x is equal to 144. I'm going to divide by 24, and I'm going to get x is equal to, let's see, 6. And then I'm going to plug back in. So one side is 9 times 6 because it's 9x. The other side is 8 times 6 because it's 8x. And the third side is 7 times 6 because it's 7x. So this is going to give me a 54, a 48, and a 42. If you added those all together, you would get your 144, which is the perimeter or the distance around it. All right, the other way to do it is a little bit harder, but it might be easier for you to see. So if I look at this as a small triangle that has sides 9, 8, and 7, when I add it up, I get a total of 24. So the side that's 9 is to the whole 24 the same way x is to the whole 144. So if I do it this way, I'm going to cross product, so I'm going to get 24x is equal to, let's see, 9 times 144, 1,296, so I'll have to divide, and when I divide by the 24, I get a 54. So that's one side. Then I would take the other side, and I would go 8 is to 24. As x is to 144. So I have a 24x is equal to 1,152. I'm going to divide by the 24, and I'm going to get a 48. So that's the other side. And then I would take the third side. 7 is to 24, as x is to 144. Side to a whole, side to a whole. So I have 24x is equal to 1,008, which I'm going to divide by 24. And it's going to give me x is equal to 42. Now notice you got the same 3 sides no matter how you did it. I just find that this side is an easier way to do that problem. All right, your homework on this is page 285 through 286, 12 through 22 even, and 28 through 34 even. Make sure it gets focused in on. There you go. Now you see it.